In this video, we're going to talk about 5 tools that you need to build your network starting right now. By the way, if you're watching this video as part of the CompTIA Security Plus study guide that I'm building for this channel, make sure you watch all the way until the end. I have something for you at the very end. Let's dive right in. The first thing that we're going to talk about is routers. Routers, along with the very last device that we talk about in this video, are going to be one of the main things that you're going to want to have on your network. Routers can use a series of access control lists to determine where to route certain traffic. Routers can use anti-spoofing technology to make sure that traffic is coming from a genuine source and not being spoofed. That basically will allow you to know that whatever web traffic is being received by a client is legit. Next, we move on to switches. And basically, switches provide a great length of scalability for your network. Basically, switches can provide a degree of port security, but the important thing to really dig in on switches is layer 2 versus layer 3. Now, what does that mean? Right here's a link to my OSI model video. Very important to understand the OSI model, where things fit in, because this is where switches kind of can get a little confusing. This is referring to layers of the OSI model. A layer 2 switch will use devices and their MAC addresses basically to segment a network into logical segment. Whereas a layer 3 switch basically can take on some routing roles along with its switching duties. So it can be a little confusing. Make sure that you know the difference between layer 2 and layer 3 switches. That may be something that you encounter later on down the road. The next thing is loop prevention. Basically, this is an availability technique, making sure that if there is a process that is looping across the network, it will kill it so that way the traffic isn't bogged down by that process. And then same thing with flood guarding, and that basically prevents denial of service attacks or any kind of like ping flood or any kind of other flooding attack that can bog down a network. A switch can automatically protect your network from that. Next, let's talk about proxies. Now, there are 2 main kinds of proxies. There are forward and reverse proxies. A forward proxy is used by the client to bypass, like, let's say, firewall restrictions. So let's say, for example, you are in an arbitrary country. Let's say it rhymes with China, right? And it might have a great firewall, let's say, that is maybe very restrictive of certain sites that you may like Twitter or YouTube or Facebook. And so you can use a forward proxy basically to skirt that great firewall and use all the great services that you enjoy. A reverse proxy, on the other hand, is basically used by server and network admins to increase the availability and performance on their network. Transparent proxies, this is pretty common. They basically they're acting as a proxy. They just don't make any changes or alterations or any kind of impact whatsoever to the data that it is being a proxy for. So think of it as a game of hot potato, where the potato is the packet. It's literally just going to take it and shoot it off somewhere else. It's not going to alter anything, turn the potato into a tomato and fling it at somebody else. It's not going to do that. Next, you got application and multi-purpose proxies. Application proxies are really probably the proxy that you're thinking of in your mind when you think of a proxy. And it is the most secure type of proxy that basically just sits between you and whatever network or service or site that you're wanting to access, right? And the traffic is being funneled through that proxy. A multi-purpose proxy is basically a proxy that can just handle multiple types of packets. So, normally, whenever you're going on the web, you're using HTTP or HTTPS types of packets. But let's say, you want to use SSH or Telnet or FTP or any other kind of service, a multi-purpose proxy would be able to handle those requests. Next, you got load balancers. Load balancers are very important. They can really help increase the scalability of your business just on the volume of requests that you can accept. And so let's talk about how load balancers work. Of course, we can talk about load balancer scheduling. We're going to talk about how it can schedule, when to shift packets from areas of demand to areas that can handle greater demand. One would be affinity. So let's say, you have certain endpoints that are not really handling a lot of requests and some that are just getting absolutely hammered. So affinity will basically allow the load balancer to start routing certain demands and packets over to the lesser impacted endpoints, and that will basically relieve some of the greater impacted endpoints. Another would be round robin, where it evenly distributes the demand across all of your endpoints. So basically, you know, one packet goes to one, and then it literally just passes through to the end of your list of endpoints sequentially, and then it starts back over, and it just kind of loops back through the list. And that helps your endpoints not get overburned, and it balances out the overall demand on your network. One way that you can do it is active passive. So let's say you have a series of devices that are actively handling requests, and then a series of endpoints that are there passively to jump in and help when needed. But generally they're there really more as a ready reserve. Whereas active is you have your primary endpoints that are used as service requests, but then you have an active set of reserves that handle requests on a much more active basis. And then of course, this is one of the most important things that you need to make your network, and that is an access point. Lord of the Rings fans, what's up? Now, how do access points work? They can use your SSID to grant you access or any other kind of authentication method. They can also filter MAC addresses. So let's say you have a MAC address that has been blacklisted from an access point. Well, that's not good. For you at least, but for the access point, maybe it thinks that that's the secure thing to do. It may filter access through signal strength, and it may prioritize stronger signals to weaker signals. And then of course, whenever we're talking about this, you want to pay attention to, well, where do I place an access point? Let's say, you're a business owner and you're just moving into a new space and you're building your network literally by hand from scratch right now. And that's why you're watching this video. What's up? Comment down below. Well, you want to make sure that you're paying attention to the band strength of your access point, and then that it can have the bandwidth output that you need to make sure that you are servicing, the kind of foot traffic, or let's say it's a public AP, like you're opening up a coffee shop and you want to provide Wi-Fi. Can your access point handle the web traffic and the demand that will be needed of it? And then of course there are types of antennas, and where it matters where you place them. So let's say you have an omnidirectional antenna. That literally means it's shooting everywhere. It can it will send out a pulse in all directions saying, hey, I'm an access point, and then a mobile device will see that pulse and say, hey, cool access point. Let's see if I can connect to it, right? There are directional antennas, meaning it'll shoot in a specific direction, and everywhere else will have a harder time picking up that pulse. There's long range antennas, so you can actually pick up pulses at a longer distance. But these matter, especially whenever you're building your network. What kind of antenna do you want? Let's say you're an attacker and you're trying to spoof an access point. What kind of antenna do you want? Do you want a long range antenna so you can sit at range and try to spoof an access point? We do not condone any illegal activity. Just don't. I only mention that for educational purposes. So those are the types of devices that you need to build your network. So if you learned something today, comment down below with something that you learned, and I might shout you out in the comment section. So stay tuned for the next video. We'll see you next time. Bye.